Good morning. So, the next topic you are going to deal with how to calculate the value of K3 when height and slope of the hill is specified. So, that is a different part. Actually, the value of K3 for such cases is obtained from Appendix C of IS 875 Part 3. Okay, so let us go to that Appendix C. So in this appendix C, there is C1. There is a term called LC or LE. That LC or LE values depends on the value of theta. Now, what is theta actually? Theta is actually this slope of the wind direction. Now, actually, theta here refers to the slope of the hill. Now, what is LE? LE actually refers to the effective length. And what is L? L is actual length of the upwind slope in wind direction, and Z is effective height of the feature. So if Z refers to the height of the hill, okay, theta is upwind slope in the wind direction. Actually, theta refers to the slope of that hill. Okay, so that is the meaning. Now similarly, from C2, from C1 you have to calculate LC or LE. Now from C2 the formula of K3 is given as 1 plus C into S. Now our objective is to find C and S. Now the value of C is also depend on the value of theta, that is theta lies between 3 and 17. C value is 1.2 Z divided by L. Actually it is divided, Z divided by L. So what is Z? Z is the height of the hill, and if theta is greater than 17 degrees, C value is 0.36. Now there is a term known as S. Now if you look at this figure, you can see what is L is marked here. So there is a portion known as crest. So from the crest to the horizontal length, that is L, then upwind slope is also shown here. So this upwind slope is nothing but the slope of the hill. Okay, now Z is marked here. Z is height of the hill. So Z is height of the hill. L is the horizontal length of the hill from the crest. Crest actually refers to the topmost point. So the value of L, you can get it from the question. Now factor S should be determined from figure 14 for cliffs and escarpments, figure 15 for hills and ridges. Okay, so if you look at figure 14 and 15, so this is figure 15. So if you look at figure 14, it is cliff and escarpment. Now so H by LE and X by LE. So for hills, H by LE has to be calculated. So H is height, and what is X? X is actually the distance from the crest. So that here it is given the distance X from the summit or crest related to the effective length LE. So X is actually the distance from the summit. The formula of K3 is given in C2. K3 equals 1 plus CS. Now for theta lying between 3 and 17, C equals 1.2 Z by L. Now for theta greater than 17, C equals 0.36. Now the value of S is obtained from figure 14. Actually it is not 14, it is 15 of IS 875 part 3, depending on the value of H by LC and X by LC, where X is the distance of the location from crest of hill. So while solving the problem, you will get a clear idea. The question is, a power plant structure having maximum dimensions more than 60 meter is proposed to be built on downhill slide near Dehradun. The height of hill is 400 meter with a slope of 1 in 3. The location is 250 meter from the crest of the hill on downward slope, and its eave board is at a height of 9 meters. Determine design wind pressure. Actually, what is design wind pressure? first you need to calculate Vz, that is K1, K2, K3 into Vb, that is with design wind speed, that is Vz, and design wind pressure is Pz equals 0.6 Vz square. Now the place is Dehradun. Now from appendix A you have to find the Vb value. Now similarly, after finding Vb value you have to find K1 value. So this is appendix A of IS 875. So for Dehradun you can see the basic wind speed is 47 meter per second. Okay. Now after finding Vb is 47. Now we need to find K1. Now K1 is obtained from table 1. So if you look at table 1, the question is, in our question, power, it is a power plant. So if you look at power plant, go to this fourth category, that is important buildings and structures such as hospitals, communication buildings or towers, power plant structures. So it is, the building is power plant, it is clearly specified, so it is fourth category. Okay, so in that fourth category, for wind speed 47, the value is 1.07. so once again I am telling the Vb value is 47. So for 47 category, fourth category, that is powerhouse, it is 1.07. so K1 value. Okay, so for important buildings such as power plant, K1 is 1.07. okay, now next you need to find K2. So to find K2 you should know the terrain category and class. Now in order to know terrain category, height of the building is 9 meters, so it is given in the question. The eave board is at a height 9 meters. Okay, so eave board is at a height of 9 meter. So that is height of the building. Height of the building is 9 meter. So depending on the height of the building, it is terrain category can be designed. And when maximum dimension is more than 60 meter, you can, from the maximum dimension, that is length, breadth and height. So out of these three, the maximum value determines the class of the building. So if you know the terrain and class from table 2, you will get the value of K2. So terrain category, actually it is given that open terrain with well scattered obstruction having heights generally between 1.5 to 10 meters. So if the height given in the question is 9 meters, so which is less than 10, if it is less than 10 it belongs to category 2. So if it is exactly 10 it belongs to category 3. Then if you look at class C structures, the structures whose maximum dimension is greater than 50 meters, so it belongs to class C. So in our question it is already mentioned the maximum dimension is greater than 60 meters. Okay, so it is belong to class C. So terrain category 2 class C, what is the value of K2? It is 0.93 from table 2. From table 2 for height 9 meters, K2 value is 0.93. Okay, now K2 is 0.93. Now in order to find K3, the question, height of the hill is specified. So let us look at the question. Height of the hill is 400 meter with a slope of 1 in 3. The slope is also mentioned. And if the location X is at 250 meter from the crest of the hill. So these three data are specified. So when slope of the hill is 1 in 3, that means tan theta equals 1 by 3 or theta equals tan inverse 1 by 3. So theta value you will obtain it as 18.43. Now after, I have already told theta is actually the angle of the slope of the hill. If you look at appendix C, in C1, LE or LC value has to be calculated. So if theta is greater than 17 degrees, so in our case it is 18.4, so it is greater than 17, it is, so LE value has to be calculated, which is set by 0.3. So what is set? Set is effective height of the feature, that is height of the hill. Now after finding LC, now the next objective is K3. K3 equals 1 plus CS. Now here C value can be calculated based on the angle of the slope of the hill. So if theta is greater than 70 degrees, C is 0.36. Okay, now C value is also calculated. Now S value has to be calculated. Now how you calculate S value? For that you have to find two terms, that is for figure 15, x by LC and h by LC, two terms has to be calculated. Here x is nothing but the distance from the cliff, x by LC and h by LC. So z theta greater than 17 degrees, so LC equals z by 0.3. Z is height of the hill, 400 meters, 400 by 0.3, so C is 0.36. Now h by LC is h is height of the building, so h is height of the, so don't get confused, h is height of the building, z is height of the hill. So h by LC, LC is value is calculated. Now h by LC is calculated, x by LC is calculated. So what is x? X is actually distance from the crest of the hill. Okay, distance from the crest of the hill, x is 250 meter, which is given in the question. Now if you look at figure 14 or figure 15, depending on the value of h by LE, x by LE, you can see you will get the value of S. So this curve actually represents, if you see figure 15, factor S is for ridges and hills. The value of S is 0.05 for this curve, the topmost curve. Then S equal to 0.1, then S equal to 0.2, then 0.4, 0.6, 0.8. So h by LE value for our question is 0.0012. So it is a very low value. So we can assume h by LE to be horizontal axis of this graph. Now similarly x by LE is 0.18. So approximately you can say S, the value of S is 1, that is the bottommost value. Now after calculating S equal to 1, K3 equals 1 plus CS, then VZ equals K1, K2, K3, VB, then P equals 0.6 VZ square.